Hi, I am SAHA. Today I will discuss about motion in one dimension. Types of motion. Basically motion is three types. First is translatory motion. What is translatory motion? Motion in straight line. Example, car moving in a road is an example of the translatory motion. Next is rotatory motion. What is rotatory motion? Motion in circular path is called rotatory motion. Motion in circular path. Example, motion of wheels of a car. Motion of blades of fan. Etc. Third is oscillatory motion. What is oscillatory motion? To and fro motion from a mean position is called oscillatory motion. To and fro motion from mean position. Example, simple pendulum. What is simple pendulum? If you hang a string and attach a bob at the end and move the bob slightly, this type of motion is called oscillatory motion. Now I will discuss some common term related to the motion. First is distance. The path, the length of path covered by a body is called distance. The length of path covered by a body is called distance. Very important is it is a scalar quantity. It is a scalar quantity and unit is meter or SI and centimeter or CGS. Okay. Second is displacement. What is displacement? The shortest distance between initial and final position is called displacement. The possible shortest distance between initial and final position. Okay, unit is same as distance, and important is it is a vector quantity. Over. Now see the figure. Let this point is A and this is B, and this is C, D, E. Now you have to say that what is distance and what is displacement. A, C, D, E, B. This is distance, which is a scalar quantity, and AB is a displacement, which is a vector quantity. Okay, and the next is speed. What is speed? The distance covered by a body in unit time is called speed. Distance covered by a body in unit time. Okay, and unit is meter per second for SI and centimeter per second for CGS. This is a scalar quantity. It is a scalar quantity. Why scalar quantity? Because distance is a scalar quantity, and we are saying distance covered by a body in unit time. So speed also is a scalar quantity. Okay, we can express speed, the ratio of distance traveled by time taken. Speed equals to distance traveled by time taken. Okay. Now, what is velocity? The rate of change of displacement is called velocity. The rate of change of displacement is called velocity. Unit same as speed, meter per second for SI and centimeter per second for CGS. And what is the this is a this is a displacement is a vector quantity, so the velocity scalar vector, this is a vector quantity. It is a vector quantity. Velocity, we can express the ratio of velocity as a displacement by time. Now I will discuss about types of velocity. First is uniform velocity and next is non-uniform velocity. What is uniform velocity? If a body travels equal displacement in equal time interval, then it is called uniform velocity. And non-uniform velocity, if a body travels unequal displacement in equal time interval, then it is called non-uniform velocity. See this with an example. Let a car in position 1 and same car in position 2, same car in position 3. Say this is 1 minute, the time interval is 1 minute. If the displacement of these two position is say 5 meter, and this is also 5 meter. Uniform velocity, if a body travels equal displacement in equal time interval. Equal displacement in equal time interval. So this condition, we can say this body is moving with a uniform velocity. Okay. And non-uniform velocity, say in the first 1 minute, the body traveled 5 meter, and then next 1 minute, say this is traveled with a 3 meter. So if a body travels unequal displacement in equal time interval is same, but the displacement is different. So in this case, we can say that the body is moving with a non-uniform velocity. Understand? Now see, what is average velocity? Average velocity is a ratio of total displacement total time. That's it. Average velocity equals to the ratio of the total displacement by total time. Okay. Now see, what is acceleration? Acceleration. The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. Unit meter per second square, meter per second square, or SI, and centimeter per second square for CGS. Okay. And the note is, if a body move with uniform velocity, then acceleration is 0. Is a very important. If a body move with uniform velocity, then acceleration is 0. Now see, we can express acceleration as a acceleration, the ratio of the change of velocity by time. Okay, acceleration equals to ratio of the change of velocity and time. Types of acceleration. First is uniform acceleration and next is non-uniform acceleration. Uniform acceleration, if equal change in velocity takes place in equal interval of time. Okay, uniform acceleration. And non-uniform acceleration, if unequal change in velocity takes place in equal interval of time. Okay. The example of the uniform acceleration is a free falling body. Explain the uniform and non-uniform acceleration with a diagram. See, there is a car in position 1 and the same car in position 2. Car position 2, car position 3. See, here the velocity is 50 meters per second, and here velocity is 60 meters per second, and here 70 meters per second. And time interval I am taking same 1 second, and here also 1 second. Now see, what is the velocity separation between this two positions? 60 meters per second and 50 meters per second. That is 10 meters per second. Velocity separation is 10 meters per second, and here velocity separation is also 10 meters per second. Okay. Both the position, both the separation, the velocity separation is same 10 meters per second, 10 meters per second, and 10 meters per second. So I can consider this case as a uniform acceleration. Okay. Now see, 15 meters per second in this position, and time interval I am taking the same, and say this velocity is 80 meters per second. Here change of velocity is 20 meters per second. So here unequal change in velocity takes place in equal interval of time. Unequal change in velocity, equal interval of time. In the first 1 second, change in velocity is 10 meters per second, and the next 1 second, change in velocity is 20 meters per second. So this case we can consider it as a non-uniform acceleration. Okay. Now the third one is negative acceleration. What is negative acceleration? If velocity gradually decreases with time, then it's called negative acceleration. If velocity gradually decreases with time is called negative acceleration. Say a car position 1 or position 2. Velocity is 50 meters per second, and after 5 seconds the velocity is 40 meters per second. Here velocity is reducing with time, so this case can be considered as the negative acceleration. It is also called retardation or deceleration. Now see this problem. A particle moved from point A to point B, traveling some distance with speed 60 km per hour. Then it returned from B to A with speed 40 km per hour. Find displacement, distance, average velocity, average speed for entire journey. Okay, let's start. A body moved from A to B. Say this point is A and B. First the body moved from A to B, and then is returned from B to A. So the distance is, so the length of the AB is D. First, displacement. What is displacement? In the definition was the shortest distance between the initial and the final position is displacement. Here initial position is A. For the entire journey, a body starts from A, then go B, and again it back in the A. So final position is also A. So what will be the displacement? There is no displacement, that is 0. Why? Because initial position is also A and final position is also A for the entire journey. Okay. And the distance. What is distance? The length of the length covered by an object, or the path covered by an object. So for A to B, the distance, the length is A to B, length is A, and the displacement is A to B, and again for B to A, distance is D. So it becomes 2D. Clear? And third is average velocity. Average velocity is displacement by time. What is displacement here? Here displacement is 0. So average velocity become 0. Okay. And the fourth is average speed. Average speed. Is this speed is distance, average speed, total distance time. Okay. What is the total distance? 2D. For A to B, D, and B to A, D plus D, 2D. And time speed equals to this speed equals to distance by time. So time is distance by speed. So for A to B, distance is D and velocity is 60 km per hour. 60. And for B to A, distance is D and velocity is 40 km per hour. Okay. So 60 and 40 LCM 120. 2D and for 40 3D 5D by 120. So average speed becomes 2D by 5D by 120. It is 2D by 5D into 120. 48 km per hour. Clear? The next problem is an object moving from right has a decrease in velocity from 5 meter per second to 1 meter per second in 2 seconds. What is the average acceleration? Is here velocity is 5 meter per second and here the velocity is 1 meter per second and separation of time is 2 seconds. Then what is the average acceleration? Average acceleration change in velocity by time. Change in velocity means final velocity minus initial velocity. Final velocity is 1 meter per second and initial velocity is 5 meter per second and time 2 seconds. That is 1 minus 5 4 by 2 is equal to minus 2 meter per second square. The answer is the average acceleration is 2 meter per second square, or you can say the retardation or deceleration is 2 meter per second square. If you say acceleration, then use minus 2 meter per second square, and if you use deceleration or retardation in your answer, then use retardation is 2 meter per second square. Okay, thank you.